Okay, so I want to give an example and look a little bit more about why we use getters and setters instead of just accessing data members directly. So just as a reminder, when we have a class, members are data that belong to the class, and methods are behavior or functions that belong to the class. So here I have set up a class card, and it simply has the initial version of it simply has two members, and I've made them public. I have a rank, which goes from 1 to 13, 1 to 10 for the ace and numbered cards, and then Jack is 11, Queen is 12, King is 13, etc. I have a suit, which is a char. I mentioned these in class, but we haven't actually used chars yet. The char is short for character, so it's a single character. We've used strings, which are a collection of characters. Char is just one byte, stores one character. And that's all I need for suit. So it's going to be uppercase C for clubs, uppercase D for diamonds, H for hearts, and S for spades. So I'm just going to go ahead in my main program and create a card as an example. So the type is card. It's my class definition. Class is a user-defined type, so I've created a type called card, and I'm going to instantiate an object called card1. Okay, I'm now going to set card1 rank, so we access members with that dot notation, so that this is saying the rank member of card1, I want to set that to be 5. And I'll now set the suit. So card1 dot suit, and I'll make that, I need to use single quotes because we're talking about a character, not a string, and I'll make it D for the 5 of diamonds. And I'll just output this now. So I'll say your card is the, and I'll print out the rank. I'll do card1 dot rank, and I'll say of, and the suit. And then I'll do a new line using the endl. And my normal kludge for debugging. And main is supposed to return an integer, so I'll do it. Although we've learned it in C++ version 11, if you fail to do that, the compiler will put it in for you. Okay, let's just quickly build that and run it. And it built successfully. So we'll give it a run, and it's just going to say, your card is the 5 of D. Okay, well, and that all worked fine and well. The issue, though, is I'm exposing implementation. I'm allowing the user to set rank and suit directly. So, first of all, because it's exposed, it's not encapsulated within my implementation of card. I can't change it now. This main program is expecting rank to be an integer and suit to be a single character D. So if I want to change how I make my card, I can't, or if I do, I have to change all the programs that use it. Whereas if I used getters and setters, what I use to store my rank and suit, I would be free to change behind the scenes. And even more importantly, now any kind of input validation or validation of rules of what are valid ranks and what are valid suits has to be done outside of the outside of the object, outside of the class. So, I could say the rank is 55, of Zs. And that's going to compile and run. Nothing's going to stop that from working. So I run it and look, your card is the 55 of Zs, which is not a valid card. But because I'm just exposing these and allowing the user of the class to change them, then I have to rely on the user of the class to read my rules and follow them and enforce them. So the better solution is to make these private. Okay, now see, as soon as they're private, you see these red squiggles. I can't directly set them anymore. So instead of directly setting them, and essentially with a variable like this, with any variable, there's only two things I can do with it. I can either read it, so go to memory and find out what's stored there, or I can store to it. I can assign a value to that variable. And we can do those two things through functions of the class rather than doing them, allowing the main programmer, the user of the class, to do them directly. So we normally call those setters and getters or access methods. So I'll just put a little comment here, access methods. So I'm going to do set rank. So they're going to be methods, which are functions, so there's going to be parameters. Set rank doesn't have to return anything. I'm not getting something, I'm setting something. But I do need to tell it what I'm going to set the rank to, so I have to pass a parameter. I think my parameter will be rank, just rank. Now, I implement the function right here. So ultimately what I want to do is just set the rank. Okay, but I want to do more than that because we do have some rules about the rank. So this would be the most basic setter. Just take whatever the user passes to me and set my member value to that. But in this case, I want to validate that it is a valid rank. So I'm going to use my if statement. Say if rank is greater than 0. Okay, now I can combine multiple logical conditions with an AND. So I can say if rank is greater than 0 and rank is less than, so what's the highest valid rank is 13. So if it's less than 14, okay, I could have said greater than or equal to 1 and less than or equal to 13, but I've chosen to say greater than 0 and less than 14. Then, so if it's a valid rank, I'll set the rank to whatever the user passed in. Now, if it's not a valid rank, I have to decide what to do. So I'm going to, for now, what I'm going to do is, if it's not valid, I'm going to set it to 0. And that can be kind of like a flag to say it's not an invalid rank or an unset card. That way, I know that someone tried to set it to an invalid number or it's not yet set. So the first thing I'll do is set this to 0, and then if the rank that gets passed in is valid, I'll reset it to the valid rank. Otherwise, it's going to be left just as 0. So that's setting rank. Now I want to do a get method to get rank. So I'm getting rank, which means I'm going to be getting an integer. The function or the method is going to return an integer. So int get rank, And I don't have to pass any parameters this time. Now, just the simple act of getting the rank, of finding out what that rank is, isn't going to change the card in any way. So I can call that a constant method. It's not changing the object. Reading the object is not changing the object. And I've already validated when I set the rank, I validated it, so I don't really have to test anything. I have to spell return right. All I have to do is return what the rank value is. So I did all of my testing and validating in the set method, and the only way this rank can be set is through this set method. So it can only have valid numbers in it. Okay, now I'm going to just do the exact same thing for card. So first we're going to do suit, set suit. And this time the user will be passing in a character variable because the suit is set as a character. Now I have a little bit of a more, the same situation. I need to have a default that says it's not been set. So I'm going to make that 0, which is a little different than blank. It's the null character. Okay, so I set suit to 0 first. That's a null character for unset. Maybe I'll just make a comment there. 0 is also known as null when we're talking about characters. So if it's uninitialized or unset, it's going to be null. And I'm just going to do something we haven't seen yet. This variable suit is a character, and I said I want only uppercase. Notice in my description I said uppercase characters. So just in case the user sends in a lowercase character, I'm going to use this standard library function toUpper to just change it to upper. So all that does is assign if suit is a lower c, this returns an uppercase c. And if it's an uppercase c, it keeps it as uppercase. So it just converts to uppercase. So that's just the first step I'm going to do that I can do in my setter to make sure I have valid data in my suit variable. And now I'm going to say, and later when we learn more complicated if statements, there'll be easier ways to do this. But for now, I want suit has to either, suit has to equal C. It's the easiest way we'll do. If suit equals C, then I can say suit underscore equal, this time it's assignment, equals suit. And I can do this for each suit. As I said, later we're going to learn easier ways to state the same logic using ifs and else and selects and logical expressions like ands and ors. But for now, this will be the easiest way. So I've got clubs, diamonds, hearts, and spades. So the point of this isn't that there could be a better way to do the if statement. This logic works. What I'm doing is I'm first, whatever the user passes in, I change it to uppercase because I only want to deal with uppercase. And then if it's one of the 4 valid things, I set suit, well, the first thing I do is I uninitialize suit. I set it to 0 to say this has not been set. Make the parameter that comes in uppercase, and then if it's any of the valid parameters, I set suit to that valid parameter. Okay, and now I have to do a getter. So the suit is a char, so it's going to return char, and it's going to be called get suit. So our getters and setters are always called get, the name of the member we're getting, and set, the name of the member we're setting. Again, getters are normally const. Normally, reading a variable doesn't change the value, any of the value of the variable or anything else in the object. And normally the getters are very simple. I just return the member value. Although sometimes getters can be more complex. You can calculate things in getters. Okay, so now all I have to do is, now instead of setting the member like this, I'm going to call the setter. So I'll call set rank and pass it 55. And I'll call set suit and I'll pass it the character Z as a parameter. And here, instead of just reading the member, because it's now private, I can't do that anymore, I'm going to use the getter. So I will get rank and this will be get suit. So in the main program, really the difference is that we're now using getters and setters to set and get these values. Now notice I'm still using invalid values here. So let's build this. And see what happens. Okay, and my card is the 0 of blank. So it's implementing my logic, and I know that it's not a valid card. I could test and see if the card value is 0, that I know it's not valid, or the suit is blank. So let's make it a valid card. And here I'll use a lowercase s for lowercase, so do the 5 of spades. Build it. And run. And here you can see it says your card is the 5 of spades. Notice it's changed that lowercase s to an uppercase s when I did that to upper, and then I set it to the uppercase value. So I'm enforcing rules, and when it's possible, when I know what the intention was, that was to make it a spade, but they used the lowercase instead of the uppercase, I can force it all to uppercase. So this is an example of creating a class with getters and setters, and I'm trying to show you the reason why we always, or some of the reasons why we always do this. Now that this program is using getters and setters, I could come in here and I could change my mind and decide that I'm going to have suit represented by a number or by a string or any of those things. It doesn't matter. I just implement the logic. As far as the interface to the class, I can still make it uppercase C, D, H, and S. I could even do something a little more complex, like have my my card represented by a number between 1 and 52. You know, the first 13 could be clubs, and the next 13 spades, and I could use a bit of logic to figure out, to map each of those numbers to a rank and a suit. The external user, you know, this main program wouldn't change one iota. It would be exactly the same, but the internals of my program would be completely changed. So that's encapsulation, which is a very valuable property, and it's a best practice. It's a good way to program. It makes your programs less brittle. Changes in one place don't cause problems in other places. Okay, so that's my example of getters and setters.